Hi everybody. Well, as I've mentioned before, I've done some work building themed environments and gags for theme parks, and I've also worked quite a bit at a local children's museum building the electronics for their displays. And in the middle of trying to do the car and trying to build my Halloween electric chair, uh, the museum reached out to me with a rush order to put together electronics for a giant-sized cornhole game. Cornhole, throwing the beanbag through the hole. This one's going to have 4 holes on it. Each hole is going to have a different point value. They want electronics that will allow 2 players to play, count up the totals for each hole. Each hole will have a different value, and display the scores on some giant 4-number LED scoreboards that they got from a display unit they ended up with from Las Vegas. And let's see, a reset button and an indicator that there's going to be 2 players playing, which turn it is. It's going to be some kind of light. I don't know what it is, so I've just got a plan for that in it. There's a possibility of later down the road adding audio to it, making it more fancy, but because we've got to rush to really get this done in about 3 weeks, it's just that basic setting right there. So I'm going to be building this using an Arduino. Let's see that or not. It's an Arduino Uno. The Arduino Unos have the R3 have 22 ports that can be inputs or outputs. On the input side, let's see, I've got stuff scattered around right now. Where did I put those? I'm going to be using passive infrared. Oh, here they are. I'm going to be using passive infrared sensors. These ones are selectable for the precision. We may end up also encapsulating the sensor end in a piece of 3/4 inch PVC to help make it a little more directional. I don't think it's going to be much of a problem though, because each slot hole is going to have MDF channel around it, so it should isolate it so we don't get false positives. These are really cheap, but they work really well. You got 3 pin inputs on it. One's a positive voltage, generally off the 5-volt supply line off the Uno, a ground or your common, and then your control line. Very simple to use. I've got 4 of those, one for each hole. And then, so I also got a backing board to help mount the Arduino a little bit better, keep it more secure. On the output side, I've got a solid-state relay. Of course, this doesn't want to open for me. Now, relays, you have the mechanical type that are just absolutely reliable, work on AC, DC, it doesn't matter as long as you don't overrun the amperage on it, but they've got that mechanical clank every time it opens and closes. The solid state is what we've been moving towards. There's a different style which is for AC only. This style is meant for DC, but I believe will also push AC without any issues. To double check on that. But these type are meant for DC. With the other style that are meant for AC, what will happen is you'll open it up and then it'll latch open until power is removed from the input side altogether. So I need to double check what kind of light they're going to end up using. I also have some DC or some AC relays laying around that are solid state, but we've made that move going there just to get rid of that additional noise. One thing else I'm adding to this. A lot of guys, when they're putting stuff with Arduinos, because Arduinos are really meant for testing more than anything, they'll use breadboards with just wires hooked in. And that's great for testing and for playing around and whatnot. But when you're building something that's going to be long-lived and you're going to have to do maintenance on later because eventually stuff breaks, I find it better to use something that has a wire terminal on it. Just makes it so that when you have to change wiring around or replace pieces later, it makes life a lot easier. And so this actually plugs right into the Arduino on either side. You can also put on additional daughter boards beyond that. But with the screw terminals going to your different inputs and outputs, so it just makes working on the device down the road a lot easier. Now, the LED unit's very, very interesting. It's not small. Let's see, that is actually quite huge, which works great with it being up higher as part of the unit. I had to do some research off the model numbers and whatnot. It's made by a company called Electronic Displays, electronicsdisplays.com. It's an ED402-117-4D-N1. That doesn't mean a whole lot until you start looking, and those call numbers give different specifications for it. This one runs off 120 volts AC. It has 4 LEDs or number panels, so you can do 4 digits. Those panels are red, and it's in a NEMA 1 standard enclosure, and it receives its information for the number based on RS-485 serial communication. Arduinos actually do RS-232 natively, kind of. It wants to do it as a TTL, but you can get add-on boards that will take that TTL and put it to true RS-232 or RS-45. So I've got a small board that should be here in a couple of days that will do the translation to RS-45. So depending on when that shows up, I'm going to start playing, making sure I've got the PIRs working correctly, making sure that I'm firing off those relays correctly, and I can even do the addition on it, making sure that the scores are being kept correctly, and just using the serial output on the Arduino IDE to make sure that math and the algorithm is working correctly. And then as soon as that TTL card comes in, or chip, then I can start interfacing with the clock or with the counter and make sure that's working correctly. I only brought one of the clocks with me, or no, I keep saying clocks, counter with me, just to make sure I can communicate correctly. And partly because they're just so big. Then once I've got all the electronics set up, then I'll take everything down, and they'll do the actual mounting. I just got to make sure it's there, and then do debugging if there's any issues once we get it there. I'm really thinking it'll only take about a week and a half to get this put together, really depending on parts getting here on time or anything. Obviously, I've got most of the parts here. I already had the PIRs and the relays. I just had to order in the Arduino, the board, the power supply for the Arduino. I do need to do a little bit more checking to make sure that the 5-volt line feeding the relays, the PIRs, and the RS-45 board, that I'm not overdrawing on the amperage available on that line. Just obviously some simple calculations there, but I might have to go with an additional external power supply for that. That's really about the only complication I foresee on this. So as I actually get stuff testing, I'll show videos on that, and I'm going to throw the code for this on not Bitbucket, but on GitHub. I use Bitbucket for more commercial-based stuff. Because it's for the non-profit, I tend to let this code out there because it's simplistic code, and if someone wants it, fine. So I'll have links to that for those that are interested and want to play with that later. And let me know when I'm doing recording in here if you want me to go ahead and actually use the chroma key and give myself a fake background. I've already got it set up. Up to you guys. Well, that's what's coming down the pike in project number 3. Thanks. Bye.